Hi and welcome back. We are going to continue practicing dilations, but this time we are going to practice it on a coordinate grid. So if you remember, the two things you need to know when you dilate a shape is what is the scale factor and where is our point of center or point of dilation. So usually when you're on a coordinate grid, the point of center is right here, and that is called the origin. So everything is going to get bigger the further it gets from the origin, and it's going to get smaller the closer that it gets to the origin. So let's start off with just a random triangle. Let's say this point here, and this point here. Let's call this point A, and I'm going to write down the coordinates of each of these points. So this one would be 3, 3, goes to the right 3 and up 3. This one is going to be 3, -1, and we can call that B. And then this one is going to be -1, -2, and we are going to call that C. And then I'm going to just connect these real quick to form a triangle. All right, so we're going to dilate this shape by 2 with our center being the origin. Sometimes they use the word about the origin, but that means the same thing. That just means we're growing from this point. So when that happens, it's magical. All you have to do is take each number and multiply it by the scale factor. So if we are going to do a scale factor of 2, I am just going to take each of these coordinates and I'm going to multiply them by 2. So 3 times 2 is 6, and 3 times 2 is 6. So my new A is going to be over 6, 1, 2, 3, 4, 5, 6, and up 6, 1, 2, 3, 4, 5, 6. And that is where my new A is going to be. And if you remember, we're going to put that little hash mark there. That tells me it's the new version, okay? And my points are 6, 6. Now I'm going to take my B point and I'm going to multiply each of those by 2. So 3 times 2 is 6. -1 times 2 is -2. So I'm going to go over 6. 1, 2, 3, 4, 5, 6, down 2. And that is where my new B is going to go. 6, -2. My new C was originally -1, -2. So -1 times 2 is -2, and -2 times 2 is -4. So I'm going to go over 2 and down 1, 2, 3, 4. My new C is right there, -2, -4. And now I'm going to connect my points to make my new triangle. Now, if you can tell, this new triangle is double the distance away from my origin, and each side length is double as long as the original. I can check it by looking at this side length. This side length is 1, 2, 3, 4 units long, so that means my new side length should be 8 units long. 1, 2, 3, 4, 5, 6, 7, 8. Perfect. Let's try dilating a shape by 1/2. Okay, I decided just to do another triangle, and I just chose a random triangle. I have point A at -7, 7. I have point B at -2, 5. And I have point C at -8, 3. And I am going to dilate this shape by 1/2 with the center being my origin, or about the origin. So I am going to take each point that I have and I'm going to multiply it by 1/2, which is the same as dividing it by 2. So let's start with point A. So we've got to think, what is half of -7 and +7? Well, half of 7 is 3.5. So this time I am going to go left -3.5, up 3.5. Okay, so 1, 2, 3.5, up 1, 2, 3.5. So that point is going to be right in the middle, right there. And I am going to label it A with that little hash mark. And that point is -3.5, comma 3.5. Okay, let's look at point B. So half of -2 is -1, and half of 5 is 2.5. So I am gonna go left 1, and then I'm gonna go up 1, 2.5. So my new B is gonna be right here. And I'm gonna write my points, -1, 2.5. Okay, and then my new C, half of -8 is -4, and half of 3 is 1.5. So I'm gonna go left 4, 1, 2, 3, 4, and then I'm gonna go up 1.5. And here is where my new C should be. So -4, 1.5, and then I'm going to connect these and make my triangle. So, as you can tell, when your scale factor is less than 1, like 1/2, your shape is definitely going to get smaller. And that goes for all numbers that are less than 1. If you have a scale factor of 0.9, 1/3, 1/7, 0.8, 80%, any of those numbers is going to make the shape get smaller. If you have a scale factor of a number larger than 1, 1.1, 10, 100, 1.5, that is always going to make your shape bigger. And then lastly, if you are dilating a shape by the number 1, it is going to stay the exact same size. I hope that makes sense to you. I am going to make one more video about dilations that gets more into percents and fractions. It's a little bit more difficult, but don't forget to give me a thumbs up and subscribe to this channel. See you soon.